Friends, Romans, and of course, Pokemon, welcome to the channel. Thanks for joining me here at the wrong side of the YouTube tracks. They like to pretend we don't exist, but we're still here. And maybe that's the way we like it. I don't know. Now, you all remember my good friend and partner in crime, Matty the Mat here, and you know what that means. We're gonna, tickle the electronicals a little bit, see what we can make. Some of you may recall that yesterday when I intimated, or perhaps even threatened, to miniaturize the dog tracker. Well, I got some good news. I think I might be getting somewhere with that. Look what we have over here, straight off the boat from China, JLC PCB. We got a couple of PCB boards in here, just dying to get out. Now, I would be lying if I said this was my first PCB rodeo, because I've made a few boards and they didn't work out so well. They kind of half-ass worked, but not, the way they should. I got real high hopes for this one, so we'll see if that pans out. Either way, I'm going to record this, so yeah. Now, if you're wondering what the frig is this guy talking about, I think maybe it's time for a tiny little primer. It's not primer. If it was primer, it would be 2 M's. Let's pretend for a second that you are the poor slave of a dog that just hates your guts and attempts to run away every chance it gets. Why you do that? I feed you. I pick up your poop. Why you always run away? Now, unless you know that the dog is going to end up at the same strip club every time it runs away, you really need to find a way of tracking it. You could, of course, buy one of those cellular dog trackers, but that's just basically strapping a cell phone to your dog. And do you really want to pay for a cell phone for your dog? Of course you don't. He hates you. And that's where this little guy comes in. It's an RFM95 LoRa module. It's a transceiver. It's a radio. It's a two-way radio even. And you can send little bits of data back and forth between these two things. So all we need to do is hook this up to a microprocessor and a GPS, and we should be able to track the dog. And that's exactly what I did. And what you end up with is something that looks a little bit like this. You've got the LoRa chip right here. There's the microprocessor. This is an Arduino Pro Mini. That's the GPS module. And we've got a battery here, of course, and a lithium-ion charger for the battery. And if you tuck it all together into a nice tidy little package, you end up with something that's like that. So the goal, of course, is to make this a little bit smaller. Not that it's terribly big, but smaller is better. At least that's what I tell my wife. I don't think she's buying it. Of course, this thing is just the tracker. You also need a receiver station and some software and some way of putting it on a map and all that kind of jazz. And if you're interested in all that, there's 3 other videos before this one that kind of covers all that stuff. Have a look at it if you're interested. Otherwise, just, strap in and enjoy the ride. What we're going to do here is try and make this a wee bit smaller. All right, enough of that crap. Let's get into it. See if these were worth the $8 that I paid for it. I'm not kidding you. I think it was about 8, maybe 10 bucks. I got 10 boards here. They're about $1 a piece. I don't know. I don't know how they do it, but I don't really care. I'm taking advantage of it. So I got 2 boards here. This is a repeater board. It's a little bit bigger, and this is the tracker board. So let's crack her open and see what we got inside. Need a knife. Let out the stink. Okay. Yum, yum. So that's it there. Let's do a little close-up, eh? Okay, so this is the tracker board, and it is 2-sided. So I got junk on both sides of this board. Not sure how wise that is. Seems to be okay from the ones I've made before. So I don't know. We'll go with it. It makes it smaller. Obviously, this is where the LoRa chip goes, and this is the microprocessor. This little guy can you see that? This right down here, AT-Tiny 1614. I went with this chip A because it's super small and it has enough pins and the right kinds of pins to do everything I needed to do with this circuit. So yeah, I tried some other chips and wasn't having too much luck. So this was the one I settled on. I like it quite a bit. And you can actually just program this chip through these 3 pins here. So I made a little Pogo Pin thing to just clamp onto there, and you can just fire new code into that whenever you need to. So kind of handy. So this side of the chip also has a place to hook on the GPS and a place to hook in the battery. And here is a USB-C charging port, and this is the switch. Now, backside, we've got basically what this is a P4056 lithium ion battery charger. So that's all smashed onto the back here. And then that hooks into the USB-C port to charge the battery. So that's it. Also, we got some LEDs, and oh, here, right, this little guy right at the corner there, that's a little MOSFET to turn on and off the GPS. It's going to be handy. I'm glad I put it in there. So that's basically it. I'm anxious to get some stuff on here and see if this works. So I'm going to go ahead and solder all the crap on here, and we'll see what happens. Well, got her put together here, and I'm a little concerned because when I flick the switch, I don't actually recall which way is on, but it doesn't matter because I'm almost certain this chip was pre-programmed and it's supposed to blink when it comes on, and it ain't blinking. So, oh crap. Everything looks generally good. I checked everything, but we'll have to maybe probe it a bit and see what's going on. Okay, so let's poke around a bit, see if we've got voltage going to any of these things here. We'll just test the battery, make sure we got some power there. Okay, so there's 4 volts coming there. And if the switch is on, then we should have, I think, 3.3 up here or here. Yeah, there we go. So the RFM95 chip is getting 3.3 volts, means the voltage regulator is working, that's good. And the microcontroller also getting 3.3 volts. That's good. So why the hell is this thing not turning on? Okay, well, maybe we'll check the ground. We'll just use continuity for that. Beep, beep. All right, let's just see if we've got continuity on there. That's good. What about on the microcontroller? Oh, nothing. Well, that ain't no fucking good. All right, well, okay, we're gonna have to look at the schematic and see what I did wrong there. Seems like, why would that not work? I don't get it. Okay, you know, let's figure it out. All right, here be my schematic for this thing, and it's broken up into these functional blocks. I don't know if you've seen this before. So this block here is the charging circuit, and these things are called net ports. And I totally resisted using these at first, but damn, they're good. So if you trace this net port, this out plus, over to here, these two things are actually connected, but they're not in the schematic other than through these things. So out from here goes through this 3.3 volt regulator, then over to the switch, and then to the VCC. And VCC has a net port, and it's connected to here and over here, and there's one over here. So all these things are actually connected, but having it in these functional blocks makes it super easy to figure out what's going on. So our problem is ground. And there's the ground for the, oh, for fuck's sake. How the hell did I do that? So you probably see the big X over top of pin 14 there. That means that pin is dead. So even though it's got this on it, I guess that means it's not going to connect them up, which is why there's no damn ground on it. Okay, well, you know, it's easily remedied. We could just jump her over to the LoRa chip or something and get some ground in there and then continue with testing it. But holy crap, that's a dumbass error. I don't even know why I would put that in there. It's just stupid. Okay, let's check the relay and see if it's, oh, for fuck's sake. Yeah. So both of them, it's a copy and paste error. I just copied the whole thing over because, you know, they're kind of the same. Well, what can you do? All right, so I just jumpered a wire between the ground pin on the microcontroller all the way over to the LoRa ground, which I know is good. So if we turn her on now, fingers crossed, yes, light be blinking. So I think we're in good shape here. We just need to test it. Now, I'm just going to say this once, and I'll probably say it a whole bunch of other times too at some point. When you turn these things on, make sure you've got an antenna connected to your LoRa chip, because I just think that if you even do it a little bit without it, it kind of buggers things up. Like there's RF feedback into the chip. First I thought that was crap, but I noticed that these degrade a little bit if you don't have the antenna hooked up, like even once. So just to be on the safe side, make sure you've got an antenna on there. when you're powering these things on. The last little bit of kit to add is the GPS module, and that's right here. It's 3 wires, power, ground, and a signal wire. And what else? I guess we need to check to see if it'll actually charge the battery. Let's plug that in and see what happens. That is good. So red light indicates that it's charging, and then when it's done, there's a LED beside it, a little green one that'll light up when it is finished. And that's about it. But will it work? If we're going to get this thing to do anything useful, we're going to have to jam a whole shitload of ones and zeros right into that tiny little hole there. And you know, back in the old day, we had to do that manually, but now we've got these things. It's a Pogo Pin Programmer. And if you're wondering, what the hell is a Pogo Pin? Well, Pogo Pins are these spring-loaded contacts here, and they're, you know, there's continuity all the way up the shaft to the top. And you can just clamp that onto your board, onto the holes on the board, and deliver your justice that way. This one I made from a design on YouTube. I couldn't find it again when I went to go look for it, but it's out there. It was okay, but it was a little hard to make. So the way this works is you take a little piece of prototype board and you solder the pogo pins onto it, which is fine. They don't really friction fit in there, but you can get them lined up and level and everything, and that works fine. But then you have to solder this header thing on, and you bridge the contact between the header pin and the pogo pin, and when you do that, everything heats up and the pogo pin falls out. So it was a pain in the ass to get all of these hooked in there and lined up. So I thought we'd take a tiny little field trip, and I think I have a slightly maybe better way of making these. So let's just look at that for a second. Not wanting to reinvent the wheel, I stuck with the same old electronic clothespin design. Nothing wrong with it, seems to work. There's a place to stick your spring here, and that fits into a little cavity, keep it from flopping around. And then there's a pin that runs through the center, if you can get it in there, and that's all there is to it. So I'll force that in later. There you go. That's the electronic clothespin. Works good. You're also going to need a few pogo pins. That's them here. I don't know exactly what size these are. I think they're fairly standard. They have a little conical tip on them so that they fit into the little hole. You can get ones that are concave for, I think, going on to pins, but yeah, you want the convex ones, I guess. So yeah, that. A piece of Vero board. Yes, Vero board is back. Not for the purpose it was intended, but it works great for this. And finally, to keep your positives and your negatives in the right order, one of these JST connectors, always helpful. Start by soldering your pogo pins onto the Vero board. And the nice thing about the Vero board is it has slightly smaller holes, which means, let's see, which way do I want to do this again? Like this. So they friction fit in there, and you can just, you know, line them up and solder them in. There's no problem with that. And for this instance, what we want is we want the copper side, how would you say? I guess down. Pogo pin goes like this, you want it down. You'll see why in a second, or maybe already realized it. I don't know. Probably. Okay, there's two, and finally, come on. Don't squeeze them too hard. They're just metal tubes, so you know, you just need a little grip there. You can just line them up nice and flat, and then solder them to the copper. All right, so you're going to want to end up something that looks a little bit like that. So then you're going to take your JST connector and put it on the back there. And then all you have to do is solder those connections in. And those are fairly quick and easy to do. You're not bridging anything. You're just going to solder down on there. And that should do it. And of course, the Vero board is going to provide the contact between there. So yeah. Easy peasy. See if I can do this without tipping it over. And there you have it there. Now, the way this electronic clothespin works is there's a little slot in the end. Whoa, you see where I'm going with this, eh? And all we have to do is slide this in there, and you are ready to go. So unlike this guy here, where you can plug your programmer in either direction, this one has its own polarity, so you're never going to jam 5 volts into where it shouldn't belong. Some of these AT-Tiny chips are programmable through this UPDI interface, and it stands for it's not universal, Unified Program and Debug Interface, I think. So the way these programmers work, they just simply clip on to those 3 holes, just like that. And then there is a USB connector, and you have to make one of these, or maybe you can buy them now, I don't know. It's a USB to TTL. You don't buy you have to buy this thing, but you have to make a small modification to it to allow you to program the PDI port. There's a little diode there that's, you can't see it, but it's there. There's a little diode there that makes this work for UPDI. So, where are we going with this? Now, if you made it this far, then you'll be pleased to find out that this little chip can be programmed with the Arduino IDE. I kid you not. And that is thanks to Spence Condi's Mega Tiny Core hardware library. So I've got the software for the tracker loaded in here, and we are going to just set some parameters. So we need to set the board to the Mega Tiny Core 1614 chipset right there. I'm also going to change the clock. Come on. I'm also going to change the clock to 8 megahertz, as it is already said. But we don't need to run it any faster because it's just a waste of power. 8 megahertz works fine for exactly what we're doing. So that's good. And select your port, of course. And finally, we need to select the programmer, which is the CH340. That's that little USB dongle that I had showed you earlier. And with that done, all we need to do is upload it, and just like any other Arduino program, you just press the arrow and hopefully it'll get uploaded. So, and there it goes. That's all there is to it. All right, enough talk. Let's see if this thing actually works. This talks to this, and this talks to my server, which allows me to talk to it. So that's basically how that's working. More information in previous videos if you're interested. We're going to turn this on, and then on the screen, hopefully at some point, it will connect up to the server and this interface here. And there we go. So we're online now. And we'll turn on the tracker. There we go. And now we should be able to talk to it. Now, when you first fire these up, they have a 999 as their identifier. So let's just see if we can talk to it. So we're going to send node 999 report. It's just going to hopefully report back. There we go. So node that this thing sent a message back saying, yep, I'm okay. Now let's try something a little more complicated. Send node 999 location. So this should report its location. And you can see it says no GPS fix. And you can see that the blue light is only flashing. When the red light comes on, then we'll know that we've got a GPS fix. So you can find out like what's going on with the GPS through this thing as well. Okay, well, just for shits and giggles, let's turn the GPS off. That's one function that is kind of new. So send node 999 GPS off. Yeah. So it got the message, and that bright LED was the startup of the like the setup portion of the program, which means the microcontroller reset itself. So that did not work. Although it did get the message, it just didn't do it. Oh, okay. I think I might know what's going on here. Just a sec. I'll be right back. All right, there we go. I've added a capacitor on the RFM95 chip. I have often found that when you get a random reset for no frickin' reason at all, it's often because there's not enough power, and that's why it resets. So hopefully adding that will solve that problem. Let's find out. Powered up, send node 999, GPS off. Come on. And yeah, okay, so that was it. So yeah, it looks like it was that. So that's good. So let's see if we can turn it back on. Send node 999, GPS on. And there we go. Back in business. Now, we got to get a GPS fix here, and we're not going to probably get one with the antenna facing that way. So let's flip her over and just wait a little bit until that flashes red. Okay, so you see we've got a lock as indicated by the blinking red light. So now we should be able to go send node 999 location. And if we're lucky, it'll send back its GPS location. And there you go. Now, you'll notice that it took a bit more time than usual, or well, how should I say this? If you've recently watched my old tracker videos, you probably recognize that the response time between these two guys is like not so great anymore. And there's a good reason for it. And it has to do with, you know, how the software works. I kind of reworked a lot of the way the communication works between these two. And I think it's better, even though it has the downside of being a little bit slower. So if you're actually interested in learning a little bit about what I've done here, you know, maybe leave me a comment. That'll encourage me to make a video about the software. Otherwise, you know, this is working. A couple of modifications and we're good to go. Now, LEDs. I was thinking about this after I got this thing together, and it's like, do I really need a green LED to say it's charged? Probably not. Plug it in, LED goes on for charging, goes off for not charging, or for done charging, right? And do I need the little debug LED? Probably not. So I'm gonna actually just kill those, and we'll obviously replace one of these things with a capacitor. And if I do that, maybe I can even squeeze this down even smaller. Okay, what's left? I guess putting it in a box. So let's do that. All right, so I've whipped up a wee case for this thing in Blender. We'll just print it out and see if we can't jam it all in there. And there we have it. Not half bad, I'd say. Slide switch and charging port on one side, clear case so that you can see all the fancy blinking lights on the inside. It's like Christmas in there, for God's sake. Anyway, this is the old one. So, you know, about the same width, a little bit squatter, a little less tall. It's getting there, right? We're not 100% there. I think it should be smaller. And what's the limiting factor? Well, it's this. It's that damn GPS. Not much you can do about the battery, but the GPS, that's where, you know, that's where you're what? That's where you're getting all your mass from. How can we fix that? Well, obviously the way to do that is to integrate the GPS onto the board as well. And I've been thinking about this for way too long and not doing anything about it. So let me show you what I got here. This little guy is a GPS module, I think. I'm not 100% sure that it's functional right out of the box, but yeah, it's very, very small, obviously. Wouldn't take up much space. And I looked up the data sheet, and then there's a like, you know, an example circuit. So I had that made into kind of a prototype board. So if I can solder this on and populate the board appropriately, I'll test it out to see if you can actually talk to it. I don't see why not. So if that works, then we'll try and integrate this thing into the module itself. But you know, it really increases the cost quite a bit. I don't know, I haven't looked up what this was, but I think I paid like, I'm gonna say $30 for this thing. So yeah, it'll make this, you know, I mean, everything else in there is super cheap, but this would be the piece that would really drive the cost up. Anyway, whatever. look for that in some future video at some future undisclosed time. All right. Anyway, so that's about it. That's all I got. This is where I'm at with it. Comments or questions, you know where to leave them. Cheers, everybody.